Good evening, class. So today is our topic remote sensing. So every year you will see that in JRF examination, 4 to 5 questions are asked, and you will see even the topper. I think topper of JRF rankers, even they do not attempt all the 4 to 5 questions, and if they attempt it, it would not be that they should attempt the correct answer. Okay, so you see, this is the very emerging field of agriculture. That is why it is giving importance to this chapter. So that is why ICR have included, or ICR is giving so much importance to these chapters. So that is why every year 4 to 5 questions is asked in JRF examination. And even in SRF examination or in NET examinations, lots of questions are asked from the soil survey part, scaling, or what is the resolutions and different types. But here you will see, to go to the chapter survey, soil survey and all, you have to understand the basic of remote sensing. Okay, so before going to soil survey part or anything, so we will start with from the very basic remote sensing. Okay, so what is this, and how it is applied in agriculture. And you will see that it is not only important in soil science, okay, but it is also used in horticulture, pathology, in every aspect, not only in even agriculture, in the forest department, military department, everywhere it is used. You will see the satellite is used for the various purposes. Okay, so satellite is also the example of remote sensing. So we will discuss it later. Okay, so these are the importance of remote sensing I'm telling you. Okay, so here you will see the basic definition of remote sensing. We'll see that remote sensing is the art, science, and technology of observing an object, scene, or phenomenon by instrument-based techniques. Okay, these are the very basic definition. Here you will see that remote sensing is acquisition of data from the distance, not from the physical contact. Here, remote is means what? Because the observation is done at a distance. That is why it is called as the remote. In our home appliances, you will see that for the TV or for the various aspect, we use remote. Why it is called remote? Because it is used at a very distance. We give that instructions and that is used. So that is why it is called the remote. And sensing is what? It is the detection of energy. So remote sensing is basically it is acquisition of data, okay, from a distance, not with the physical contact. And you will see how it is related to our agriculture, because you will see that from the satellite data or the various data, we acquisite the data of the land or the cultivated land or the various. Okay, that is why it is called the remote sensing. So here in this image you will see, okay, that a satellite is there and it is, okay, it is taking data from this place. So here you will see it is not in physical contact with this place, it is at the far distance. So that is why it is called as the remote sensing. Sensing is it means it is detecting some energy from this place to this place. Okay, here in this image you can clearly understand that what we would need for the remote sensing process. Here you see a energy source. Okay, in our nature, sun is the main source of energy. Okay, sun is emitting energy. It is going through the atmosphere where it is having the collision with the, or scattering with the cloud. Okay, wait a second. So here you will see that these energy sources having interaction with the cloud, or then it is reaching to the our earth. And on the earth we have different types of objects. Okay, here it is the building, trees. Okay, so having the different type of the interactions, what happens that here the different type of the object behave in different way. Okay, for example, in last class I have already told you guys that for vegetation it reflects more of the near infrared radiations than the visible radiations, you see. So here you see basic principle of we see that whatever object is having, we see in usual day the color, we say that it is reflecting that color. If you see an object with the green color, what we say? We say that this color we are detecting this is just because that object is reflecting that color. अगर हम लोगों को कोई ऑब्जेक्ट जो अगर वो ग्रीन कलर का दिख रहा है, इट मीन्स व्हाट कि इट इज रिफ्लेक्टिंग दैट ग्रीन कलर्स. दैट इज व्हाई our eye is also a natural sensor. Okay, so that is why our eyes are capturing those green color, and that is why we are clearly saying that this object is green in color. Okay, the same way here it is the sensor. Sensor means our eye. For example, our eye, so it is detecting the reflecting or the emitted radiations from those objects. Okay, and those data, whatever it is of those sensor is obtaining from that place. Okay, it is in the digital form or it is in the software form. Okay, so for the we common people, it is not understandable. Okay, we cannot understand easily. So that is why those data are then getting processed. Here it is the processing station. Here you will see, here it is the used as the GIS, geographic information system. You will read it later. Okay, so GIS is what? It is the collection, storing, and processing and interpretation of data. So from the sensor, okay, then those data are collected, stored, and then that it gets processed, or then it get interpreted. Okay, so that is why it is called GIS, and here it is the sensor. Now sensor having the another part, GPS, we call as the GPS. What GPS tells us? It tells us the location. Okay, global positioning system, right? Full forms are also asked in examinations. Okay, so GPS, what it tells us? It tells us the location of that place. So here, that is why, when I was preparing for the JRF, I would to understand that remote sensing, GPS, and GIS all are same thing. That is why they are in the same chapter. But this is not actually. Here you see remote sensing a different part, GPS is different, and GIS is different. Okay, remote sensing is what? Remote sensing is just sensing the data. Here you see these all phenomena comes under the remote sensing. Okay, and GPS is telling us the position and the location of that place. Okay, that is a different thing, and we need to know the location. Okay, it is important. Without knowing the locations, those data will not be important for us. Okay, so that is why GPS is important, and then it is here comes the GIS. Okay, so GIS is basically the data which is stored, collected, and then processed, and then those data are then get analyzed by the scientist, and then it is applied. Okay. So here you will see that different type of maps are there for you would see in very in all chapters, or where we comes through the different types of the map, and those maps are created by only this data, and these data are collected by what? Sensors. See, satellite is not a sensor. Satellite is just a carrier, okay, which carry the sensor. So satellite do not gives us data, only the sensor gives us data, which is attached with this satellite. You will see in next slide. Okay. Here, remote sensing process. What are the different types of the process? In this image, I have told you that how it is get processed, but here these are the steps, different steps. Here you see the process in remote sensing involves an interaction between incident radiation and the target of interest. Okay, so there are the 7 elements. First is the what? Energy source or the illumination. In this image, I have told you now that we need an energy source which gives the energy or the electromagnetic radiations. Okay, that should be reflected or emitted by the object. So at first we need a resource, energy resource. So it can be both type of later on I will discuss that there are the two types of the sensors on the basis of the energy source, passive sensors and the active sensors. Okay, so what is this? It eliminates or provides the electromagnetic energy to the target of interest. Okay, so here you see that active sensors are those, passive sensors are those having the energy source from the sun, which uses the sun's energy. Okay, but in the active sensors, the sensor itself provides the energy source. Okay, later on we will discuss it in details. Okay, so next point is what? Radiation and the atmosphere. You see, whenever the energy source is, okay, it is emitting the radiations. Here it comes through the atmosphere. We cannot neglect the interaction of the atmosphere with these radiations. Okay, either it may be the energy source, sun itself, or the sensor itself. Okay, so active or passive sensor, so here it interact with the atmosphere. Why? Because in atmosphere there are different types of the particles: oxygen, water vapor, different types of the molecules, dust, clouds, various type of that is why we cannot ignore this. So we have to understand these steps also, that as the energy travels from its source to the target, it will come in contact with and interact with the atmosphere. So it passes through. This interaction may take place a second time as the energy travels from the target to the sensor. Why this is called the second time? Because the first time it will be interact with the atmosphere, then secondly through the target. Okay, if cloud is there, okay, so then what will happen? That energy will interact with clouds first. Then if it will be passes through, then it will comes to the target. If it will interact with the clouds, there will be different types of the phenomenon, diffused radiations, or the specular reflectance. Different types of the processes will be there. Later on we will discuss it. Okay, so in next step, what will interaction with the target? Then it will interact with the target, and once the energy makes it way to the target through the atmosphere, it interacts with the target depending on the properties of both the target and the radiation. So this is the main step. Okay, interaction with the target. And what happens when it interact with the target? Okay, when it interact with the target, you will see there is a properties of the different types of the object, that it reflects back a specific kind of radiations always in a specific wavelength. That is why it is the application of remote sensing. Here you see, then those energy which is reflected back through the object, that will be recorded by the sensor. Okay, and then when it is recorded by the sensor, then it will be transmitted, then it will be received at first, then it will be transmitted after the processing. So the energy recorded by the sensor has to be transmitted often in electronic form to a receiving and processing station, where the data are processed into an image. For example, you see NASA is what? NASA is an agency, okay, which, or in our India it is what? ISRO. What it does, it collects the data from the different types of the satellite, from the, so here this step, transmission, reception and processing, we can say it happens in the ISRO or and in NASA. Okay, and in what form? In the form of the hard copy or the digital image. I told you now that those energy which is sensed by the sensor, it will be in the in software, and which we cannot read easily. We cannot understand those data. So that is why it should be interpreted in easy language, or in the as in the image form. Okay, so next step is interpretation and analysis, on the basis of which we interpret that. For example, we see we are studying agricultural land. Okay, so an image is produced in this step. Okay, that in those agriculture field there is what? An image is produced, okay, in the digital image. So here you will see that on the basis of that image we can interpret it that, okay, this type of the cultivation is going on there. Okay, this type of the cultivation is going there, rice is there, paddy is there, tea is producing there, whatever. So on the basis of that image, we interpreted that, and then we can analysis that as a scientist, and then we can apply those data in different field. Okay, so these are the basic steps of remote sensing. Here you see sensors and platform. I told you that satellite is not a sensor. Satellite do not give us the give us the data directly. That is the sensor which collects, okay, which collects the electromagnetic radiations. So platform is there, that carrier bed used to carry a sensor. So different types of platforms are there, like this satellite. Here you will see. These are the different types of the platforms: aircraft, satellite, and the ground based. Okay, nowadays drone culture is going on in our agriculture also, very emerging. So that is also a ground based. Okay, so in drones, what is there? That is there is a sensor. Okay, so here these are the different types of the platform. Okay, now we will discuss the different type of the satellite. This is also very important to understand the concept of satellite. Okay, so okay, so I think in class 12th you have already learned this topic, that there are the two types of the satellite: geostationary and the sun synchronous. Okay, so geostationary is what? In geostationary satellite, periods of satellite is equal to the period of Earth. So that is why it seems that it is at the fixed position. Okay, and orbit at which the period of the satellite is equal to the one sidereal day, that is the 23 hours 56 minutes 4.09 seconds. This is the accurate, and overall we say that the 24 hours in a day. Okay, so that is the geostationary type. And here you will see the most important to notice the point, that geostationary orbit is like this. It is moving around this like in the orbit position. Okay, through the, you will see that through the latitudinal, okay, through the latitudinal position, here you will see. But what happens in sun synchronous? It is moving towards pole to pole, here from like this. But in geostationary, what? Moving around like this, around the Earth. Okay, but in sun synchronous, it is moving like this. So what happens in sun synchronous? Why it is called sun synchronous? Geostationary means what? Geo means Earth and stationary means constant. So with respect to the Earth, it is like the stationary, because it is moving with the same speed of the Earth. Okay, but in sun synchronous, what happens? The satellite passes overhead at same local sun time of day. What does it mean? It means, you will see that, for example, in Delhi, if it is here, the satellite, if it is crossing at Delhi at 10 a.m., okay, 10 a.m., then in Kanyakumari, when it will reach to the Kanyakumari, there will be the same time, 10 a.m. That is why it is called the sun synchronous, with the same same local sun time of day. Okay, in India, if it is crossing at the 10 a.m., then in another country, when it will pass through, there will be also the same time, or the 10 a.m. That is why it is called as this at the same local sun time of day. That is why it is called sun synchronous. Okay, so these are the important points to understand. This is the actually concept here. I cannot say that question will be asked from here, but this is the important to understand the concept of satellite. Okay. This is the important slide for you guys, that questions can be asked from these slides. That there are different types of these satellites, and which satellites belongs to which country. So Landsat from the USA, Spot is from the France, IRIS, that is the full form is Indian Remote Sensing. Okay, that is from the India. NOAA, Econos, these both are from the USA. And this slide is important. I think you should note this, or you can take a photo or a screenshot or whatever is possible. Okay. And there are different type of the GPS also, that is also important. Okay, now the main important or the base of the remote sensing is interaction with the target. Okay, in details we are discussing here that what happens when it interacts with the target. There are the three phenomena which can happen: either the absorption, transmission, or the reflection. Okay, absorption is what? It is getting absorbed. In this image you can see. Okay, if the electromagnetic radiation is coming on this leaf, so either it will be absorbed, it will be some amount will be reflected, or some amount will be transmitted. Okay, so there are two types of the reflection: specular or mirror like reflection it is called, that happens on the smooth energy is directly directed away from the surface at the single direction, or we can say that at the same angle, but in the opposite, which we study in the mirror law of reflection. So that happens in the specular reflection. But diffuse reflection is what? In every direction. Here you see uniformly in the all direction it is get reflected. That is why it is called the diffuse reflection. It happens in cloud actually. You know, cloud diffuses in every direction. Or there are lots of the object which with different type of the wavelength it can diffuse. On the basis of, here you see, the most Earth surface features lie somewhere between perfectly specular or perfectly diffuse reflectors. Okay, it is not the idea. Earth is not ideally following the specular reflection or ideally following the diffuse reflectors, but it lies in between because there are different types of the object. So it depends on the surface roughness of the feature in comparison to the wavelength of the incoming radiation. Here you see there are different type of the objects. Okay, later on I will come to this slide. Before this, you should understand the spectral signature. Okay, what is the spectral signature? This is the, you know, for agriculture point of view or as a soil scientist, we need to study only the vegetation part, soil part, and the water part. Okay, vegetation, soil, and water. Okay, for the that is for us applied part in agriculture. So spectral signature is what? For any given material, actually this is the interaction of some electromagnetic radiations, okay, with the objects like what? Different type of the objects, but we will focus only on the vegetation, water, and soil, which is related to our study. So this is what? For any given material, the amount of solar radiation that is reflected, absorbed, transmitted will vary with the wavelength, and this importance property of the matter allow us to separate distinct cover type. Okay, so this is called as the spectral signature because different type of the object behave in the different way. Here you see, for example, here this is the spectral signature. This graph is very important, and from this graph many questions is asked. Here you see, we need to understand this graph at first. Okay, so here you see, here this one is what? Vegetation. Here vegetation, you will see that there are 2 points where it is absorbing the maximum light. Okay, that lies in the blue and the red. You know, blue and red colors are absorbed by the chlorophylls. Okay, that is why in both regions, okay, it is getting absorbed. So here depression like curve is formed, and here it is again getting reflected, and at this point at the 1400 nanometer, okay, another depression is formed, and then here at 1900 nanometer, here also another depression is forming. See, this is the behavior of the vegetation. What it does, that at this particular wavelength it is getting more and more absorbed, and at this particular wavelength. Okay, you people are understanding now? Any doubt?
Yes, ma'am. Got it.
Okay, so this is the behavior of vegetation. Okay, and here you see dry bare soil. Actually, dry soil means what? Here no water molecule is there, so it will not behave like the water. Okay, here you see this is the water. How it is behaving? That water is reflecting some radiations in the visible range only, and some to the infrared, near infrared. Actually, it is not infrared, but you will see up to 0.7 it is reflecting, or we can see that at the visible range only it is reflecting. But as the wavelength increasing here, it is absorbing all the radiations. So this is a very important point to note, that water, what does it? Absorbs all the radiations in the infrared regions. Okay, here you see that different types of the object is behaving in different way, and that is the property of based on this we are applying it as the remote sensing. Okay, here you see dry bare soil having no water molecules, so it is what? It is reflecting infrared radiations also. But if it is the wet soil, what would happen? In wet soil there is the water molecule, so in infrared region there will be absorption more and more. Okay, so this is, you do not need to note this data 1400 nanometer and 1900. In another slide it is I have given you this data in as a table form, that will be important. Okay, so this is called as the spectral signature. Signature means what? Every person have the unique type of signature. Okay, so in the same way every object having the different type of the property, that is why it is called that is why it is called as the signature. And spectral means what? So solar radiations, different types of the wavelength, that is why it is called as a spectral signature. So here in this image you can see, here it is the vegetation. What it will do, it will absorb in 1400 nanometer infrared and 1900 nanometer. But here water, what it does, it absorbs all the infrared radiations. Okay, here it is also the vegetations. Okay, here what sensor does. So what it is absorbing, water is absorbing infrared radiations more and more, so it is reflecting visible range. So sensor detect those radiations which is reflected, which is reflected back from the object. So water is emitting what? Water is emitting visible range. Here you say visible range, but plant is reflecting what? NIR more, or the infrared radiations you see more and more. Okay, so that is the different type of the property. Now on the basis of more and more resolution, you will see that this plant area is more than this plant area, right? So what will happen? NIR will be radiated more from this area in comparison with this area. So on the basis of that, this satellite gives that here it is the more vegetation and here it is the less vegetation. Okay, and here it is the water body. Okay, so on the basis of like this, the sensor detects the data, and then we can detect that what kind of the object is there. Okay, so up to here, any doubt? You can ask if there are some points you have not able to understand till now. Anyone? Any doubt? Okay. So now here it is the, again it is the vegetation, right? So here you see that vegetation is reflecting more in maximum in infrared region than the visible radiations, right? And here this blue radiations is absorbing, Here red radiations is getting more absorbed by the chlorophyll. Okay. So that is the same thing. Here again it is the different types of the water. Okay. So here, on the basis of these reflections, we can also determine that these waters is what? Ocean water, either the turbid water or the water with the chlorophyll. Okay. So these are the applied part. So longer wavelength visible and near infrared radiation is absorbed more by the water than the shorter visible wavelength. Thus, water typically looks blue or blue-green due to stronger reflectance at the shorter wavelength. Okay, these questions can be asked in the form of the assertion reason or okay. And darker if viewed at red or near infrared wavelengths. Okay, if there is suspended sediment present in the upper layers of the water body, then this will allow better reflectivity and a brighter appearance of the water. Okay. So here now we will move towards the Indian remote sensing satellites, which from where questions can be asked from the resolution. And so here, see, these are the different types of the platforms. Only two columns are important in this slide. Okay, these are the different types of the platform, and these are the different types of the sensors. At least you should know that there are the different types of the sensors and the name of those sensors and the resolutions. In the next slide it is there. Okay, list 1, list 2, list 3, pan. Okay, here you see this is the data taken from the list 1. Okay, here it is 72 meter is the resolution it is written. Okay, so and here you see this is the another data which has been taken from the list 2 having the resolution 36 meter. Here is a numerical value is more in 72 meter than this 36 meter, but resolution you will see that it is better here. You can see clearly in this image 36 meter than this 72 meter resolutions taken from this one data. So it will be resolution will be discussed in later on. I will discuss. Okay. So this is the pan data. Panchromatic data is always black and white in color. Okay. So its resolution is 2.5 meter. Okay. These are the list 3 data. List 3 and list 4 data is important. Resolution is important. It is 23.5 actually. And list 4 is resolution having the 5.8 meter. Okay, there are different types of the sensors. Already I told you that there are the two types of the sensors, passive and the active. Okay, so passive sensors are what? Collect the electromagnetic radiations in the visible and infrared part of the spectrum. Okay, and here the source of the energy will be sun, always. Okay, for example, the aerial photographs, or for example, camera we use in our phone. We, in night what we do? We on the flashlight. So flashlight is what? We are providing another source of electromagnetic energy. Okay, so that will be example of the active sensors. Okay, there is no sunlight present, no natural light is not present, so we give artificially light that, in the form of the flashlight. So that will be example of the active sensors. But passive sensors are what? In the day whenever we take the photos. Okay, so and important point is what? In passive sensors, visible and infrared part of the spectrum is used. I think in 2019 or 20 question was asked that which form of wavelength is used in remote sensing: infrared, red, blue, green, kind of. So answer will be infrared. Actually all the wavelengths are used, visible, blue, all the bands are used, but most importantly actually infrared is used. So that is why the answer will be infrared. And here you see in passive sensor it is used, visible and infrared. And example you should note, okay, that quick bird, Econos, these are all the passive sensors, not the active sensors. In the form of the matching, these questions can be asked. So active example of active sensors are what? Radar, lidar. Okay, why? You know, in radar and in lidar, what we give the microwaves. We use as the microwave as the source of energy. So that is why it will be comes under the active sensors. Later on, I will discuss the microwave sensors. Okay. Here you see these full forms are important for the abbreviation. Okay. Like the list, linear imaging, self-scanning. Okay, this can be asked. So this slide is important. You can note down. Here you see advantages of remote sensing. You know, we can globally cover we can say that the very large geographical area can be covered by the remote sensing, any data. Okay, so first one is what? Global coverage we can do for the any weather forecast or any cyclone or anything for the other than the weather forecast, any data or the, you know, greenery, forest, anything, any data we can add the very large number of the large area of the geographical area, we can use the remote sensing. Okay, and synoptic view for the weather forecast it is used. Okay, and repeatability means at the same point, for example in our agriculture, that before 2 years what plants were cultivated in some area, we can know through the satellite data at that time. Okay, for example, that 2 years ago, at the Bhagalpur, which crops were taken at the farm of agriculture university. So if we have the satellite data of that time, we can know. Okay, so repeatability means what? Repeatability means repeating of the data at the same location. Okay, and the cost, obviously it is the cost effective for the large geographical area. Okay, so these are the some advantages of remote sensing. Okay, these are not from the agriculture point of view, it is necessary that crop yield prediction, crop condition, soil erosion, it can be done. Okay, these all points how it is used in agriculture I will discuss in NDVI. Okay, if you will understand NDVI then you will understand the application of remote sensing in agriculture. Okay, so later on I will discuss NDVI, where at that time I will discuss this point, that in agriculture how it is used. So there are different types of the resolution. Every year question can be asked from this. I think in 2020 in JRF examination, question was asked from the resolution part, and there was the matching that spatial, temporal, and spectral, and in one column, and the another column there was given numerical values. So what will be? So here to solve those type of questions, you need to understand the concepts of resolution. So at first, what is the resolution? So resolution is the ability of the system to render the information at the smallest discretely separable quantity. In the for example, in the microscope we also use this term resolution, and we read there that resolution is what? That at what is the minimum distance where we can discretely identify objects. Okay, so what for example, list 3 is having the 23.5, right? 23.5 na, list 3 or list 4? Okay, list 4, right. List 3 is 23.5 resolution, and list 4 having the resolution of 5.8 meter. So what would say that which list 3 or list 4 having the highest resolution? List 3 or list 4? Anyone? Which having the highest resolution? List 3 or list 4?
List 4.
Obviously, right. List 4. Why? Because it can distinguish between the discretely identify between the two objects at the distance of what? 5.8 meter. Up to 5.8 meter, it can distinguish. But here in list 3, up to 23.5 meter only, it can distinguish. Okay. So obviously, highest resolution in the list 4. So question will be in those form directly from the resolution. Okay, and another one, yeah, relationship between the resolution and this numerical value. So it is indirect inverse relationship is there with the numerical values and the resolution. Okay, these things to remember. So there are the 4 types of the resolution: spatial, temporal, spectral, and radiometric. Okay. See, first one is the spectral resolution. So what is the spectral resolution? It describes the ability of a sensor to define fine wavelength intervals. Spectral means what? There are different types of the radiations, different types of the bands. That is why it is called the spectral and resolution. Why? Here you see, for example, there is the 2 types of these sensors. Okay. In first sensor, there is the what? Combination of blue, green, and red in the same proportion, you see. So when this satellite will sense the data from the combination of blue, green, and red in equal proportion, what it will give? It will give only black or the white field. Why? You see, when these 3 basic colors in equal quantity, equal proportion will be absorbed by any object, then it will gives what? White color, right? White object. Okay, but if these colors are not present there, then it will give the black color. Okay, if it will be, if those objects will reflect all these 3 colors in equal proportion, then that object will be white in color. Okay, so here you see, in another sensor there is the blue band also, green band also, and the red band separately. Okay, so this sensor will emit blue, this sensor will emit green, and this sensor will emit red. Okay, so on the same object there is 3 types of the wavelength of the band is coming. So it will interact different way with the blue, differently with the green, and differently with the red. Okay, here you see in the next slide. See, these are the for the Landsat data. Okay, it is the Landsat data. There are the different types of the band. Okay, band 1 is containing the blue, band 2 is green, band 3 is red. Okay, these are the different types of the band. So here you see, when we will combine 3 to 1 means what? Red, green, blue. So this type of the color is, this type of the image you will get. But if you will combine 4 to 1 band, this type of the image is formed. So if you are giving a different types of the band, so you can get multiple image of that place with the combination of the different bands. Okay, but if you will give only one color, or here you see blue, green, red in this equal proportion, then you will get only black or white film. So these are the what? Spectral resolution. If you will, hyperspectral term is there in remote sensing. What does it mean? It means even in blue color, here you see 0.4 to 0.5, this range is there, but in between these also there are number of bands, 0.41 to 0.42, another band is there, 0.42 to 0.43, another band is there. So multiple number of bands is there. That is why it is called hyperspectral. So as much as number of the spectral band will be there na, so it will give more and more information about that place. Okay, that is why it is called as the spectral resolutions. So number of bands will be there, so it will give more and more information. Here you see in this image there are number of bands, so there are number of the formation of images. So from why it is done na, for example, you see here it is the water body. Okay, in this image water body is not detecting clearly. Okay, for example, so in another image what it will be you can detect. So different type of the object will be easily understand. Okay, you can easily understand in different type of the formation of the band, for example, like this. Okay, so that is called the spectral resolution. So with terms of the wavelength there will be spectral resolution. Okay, later on I will discuss this true color and the false color image. Have you read somewhere FCC, false color composite, and NCC, natural color composite? Have you read somewhere in remote sensing?
Yes, ma'am. Yes, ma'am. I
Do you,
will read, ma'am.
do you
Suman,
understand what
ma'am.
is FCC?
Yes, yes. I बहुत अच्छे से FCC, that means it's about the color composition that uses for band. It's not a real color. We give one color to each bands. There are the three bands have three different colors.
Actually,
I
see,
just
what happens. Okay, Smart. See, actually, what happens
yes, yes.
now? We already read that what vegetation, what does vegetation reflects more and more in what band? In infrared band, right?
Yes.
In infrared band.
Yes,
So,
ma'am. Yes, ma'am.
but you know, our human eyes cannot detect the infrared radiation. Can we
Yes, yes.
see infrared radiations? No, obviously not.
Mhm.
Okay, so in satellite, if there is the, you know, infrared band is there, okay, and another is what? Red, and another is green. Okay, generally blue is not used because blue scatters most. You know, that is why our sky looks blue in color, because it gets scattered more and more with respect to other colors. Okay, because of the lower wavelength. Okay, so here you see infrared radiations we cannot detect with our eyes. That is why, and for, you know, see, satellite, what does it? Senses the data. Okay, if satellite is sensing the infrared radiations from the vegetation, how it will tell us that this is the vegetation? It will tell us that there is the infrared radiations. Okay, and how we will understand there is that is the infrared radiation. So to understand those bands, we gave the false color. For example, infrared, we gave the infrared as the red color. Okay, and red to green, I think. Yes, and green to blue color. See, this is the natural color. Actually, this is the natural, but this is the FCC, means false color composite. We are compositing it, okay, to understand. See, in this image and in this image, this is the true color. Obviously, wherever is green in color, na, that means there is the vegetation. But here, this is the satellite data. Whenever is the green color, na, here you see red in color, right? So this red in color is showing us the vegetation. Why it is? Because it is reflecting more and more infrared radiations. Okay, so we have given the satellite to convert infrared to red color band. Okay, to understand. So that is why it is called the false color composite. Obviously, this is not the that red color is not the color of the vegetation here. Obviously, green color is there, not for vegetation. But to understand, that is why we have given the green color, a red color to vegetation, and that is why in satellite images we always see red in color for vegetation. This question is asked. For vegetation, which color is used? For a cloud, which color is used? Like this. Okay. So this is the concept behind the FCC and NCC, natural color composite. Any doubt? किसी को समझ नहीं आया हो, फिर से समझाना जरूरी तो।
मैम,
यस
मैम, सो बेसिकली आप मतलब हमें ये बता रहे हो कि जो एफसीसी है, जो सैटेलाइट डाटा हम कलेक्ट करेंगे वो किसी और कलर का होगा और एफसीसी उसको इस फॉर्म में कन्वर्ट करेगा जो हम देख सकते हैं।
हाँ, ये डिफरेंशिएट करने में इजी होगा ना, क्योंकि हम लोग एनआईआर को हम लोग डिटेक्ट नहीं कर सकते ना, हम लोग डिफरेंशिएट नहीं कर सकते।
हम अलग अलग जो नहीं, उसको हम भी रेंज के कहते हैं ताकि हम सेंस कर सकें। बस यही एफसीसी है। क्या मैम? दैट्स एफसीसी। हेलो।
एक्चुअली तुम्हारी आवाज कट रही थी सुमन।
ओके ओके मैम, नो प्रॉब्लम।
ओके हाँ, जो भी तुम बोले होगे सही ही बोले होगे आई थिंक।
We have a few else then, ma'am, that I can gain from you. I will tell you in simple language. Ma'am, please continue, ma'am.
हाँ हाँ ओके ओके। Actually, in satellite, na green color is not detected easily.
Yes, yes, ma'am.
That is why it is given red color to to vegetation or to green color. Here another one is the spatial resolution. Spatial resolution is what? This is the physical dimension on the earth is recorded. Means it is distance, okay, between is on the basis of a scale, okay, key at up to what distance it can give us the differentiate between the object. That is the spatial resolution. Here list 3 there was the 23.5 meter, and in list 4 that was the 5.3 meter. So that is the spatial resolution, okay. It refers to the amount of detail that can be detected by a sensor, okay. And another one is the temporal resolution. Temporal means it is related to the time. So at the same place, in different time, when we take the data, or when we that is known as the temporal resolution. So represents the frequency with which a satellite can revisit an area of interest and acquire a new image. So today one satellite is covering this area, and another day the same satellite is covering the same area, okay. So it will give the different data, different images of that places, if there anything is changed in that place. So that is giving us the temporal resolution. Question was asked like that in one column spectral resolution was there, name, spatial resolution, temporal resolutions, and in another column it was like the 5 days, okay, and 5 days like and 5 meter. So whatever is in meter it will comes under the spatial resolution, and whatever comes in the time, or it is given as the time, so that will be comes under the temporal resolutions, okay. And in different numbers of bands, so that will be comes under the spectral resolutions, okay. So these are the types of the resolutions. So these are the application demand for the temporal resolutions. Okay, for exam point of view it is not important, we can skip it. Here see this slide is important. Here this column name of the satellite and the different types of the resolutions. Only the spatial resolution is more important for us actually, okay. That here you see list 4 5.8, list 3 23.5, okay. And questions can be asked that which satellite having the maximum resolution, spatial resolution. So here you see maximum resolution is of Cartosat 2B, that is the 80 centimeter or 0.1 meter, okay. So another is a thermal infrared remote sensing. This is also a part of actually in agriculture we use only most importantly the infrared and up to infrared region, okay, near infrared region. But thermal infrared region is also important for the different type of like urban heat temperature, or for the temperature measuring of any place na. Thermal infrared remote sensing is important, because why it is called thermal infrared, because it is it is using the range of 8 to 14 micrometer range of the, and that comes under the thermal infrared radiation. That is why this is called as the thermal infrared remote sensing, okay. So for the calculation of the land surface temperature, temperature of any surface of soil in agriculture field or anywhere. So for that we need thermal band or data of the thermal radiation. So this is here only this wavelength is important, okay, for exam point of view. So, the main difference between the thermal infrared and near infrared is that thermal infrared is emitted energy, whereas the near infrared is reflected energy, similar to the visible energy. So this is the main difference between the thermal infrared and the near infrared. Okay, it is reflected in near infrared, and in thermal infrared it is emitted. Emitted means what? It is absorbing at first, and then with respect to the temperature gradient, it is emitting. Okay. So here, microwave region. Here, this wavelength is important. 1 mm to 1 meter. Okay. So microwave region, microwave remote sensing, like the radar and lidar. Okay. These uses a wavelength of the 1 mm to 1 meter. So this wavelength is important. And here, this point is important, that due to having the longer wavelength in microwave radiations, it can penetrate through the cloud, fog, haze, etc. As the longer wavelengths are not susceptible to atmospheric scattering. See, I told you now that blue color scatters more. That is why and that is just because of the lower wavelength. Due to lower wavelength, it scatters more. So that is why our sky looks blue in color. So microwave is having what? Longest wavelength with respect to the infrared and visible range. Okay, so it can penetrate through the cloud, fog, haze. So for the any data, when we cover of the place now, when we take if the satellite is taking, so if there is cloudy or winter season, so for the different type of the weather is there, so it will not hinder. So microwave region is always is very beneficial at for that place. Okay, wherever is cloud and fog, and for the different atmospheric condition is there. If here, these are the different types of the terminologies there, and different these points are important. Okay, this definition is important. Here you see irradiance and radiance. The difference between the irradiance and radiance, it can be asked. These are the very peculiar points that will be important. Okay, so you can take the screenshot or photo. So most important topic of today for our agriculture point of view. Okay, NDVI. What is it? It is the normalized difference vegetation index, and you can see it is the application of, it is what? It is the application of remote sensing here. अगर NDVI समझ में आ गया तो रिमोट सेंसिंग समझ में आ गया, उतना तो समझ में आ गया जितना एग्रीकल्चर में इसका यूज है. ओके, सी NDVI is what? It is the ratio of, here you see, differences of NIR reflected. Actually, this is the reflected NIR minus red region divided by NIR plus red. So red is what? In the visible range. Okay, so on the basis of these, different type of object can be distinguished. How? See, range of the, see, what will be the range of NDVI? 0 to 1. Okay, even this question was asked in some examination. I think not 0, sorry, it should be minus plus minus 1 to plus 1. Okay, minus 1 to plus 1. Range should be minus 1 to plus 1, not 0 to 1. I think in some examination this question was asked, range of NDVI. So how it will be? Range vary from plus 1 to minus 1. Here you will see that what? For the vegetation, you see, it reflects more and more NIR. Okay, so this value will be greater. Okay, and this value will be low. So here you see this I think, okay, see, and negative values of the NDVI values corresponds to the water. Here see, for the vegetation, NIR will be more reflected. So this value will be more. For example, if we have the plant, okay, here you see, so it is reflecting more. For example, 0.7, 0.7, okay. So if 70% of the radiations is reflected or in the NIR region, okay, and then 0.3 or 30% is reflecting in red band, in the red region. So what will be the NDVI value of this plant? Here you see 0.7 minus 0.3, what will be? 0.4. Okay. 0.4 divided by 1. Here NIR plus red. So what will be the value? 0.4. Okay, so it is coming in between here 0 to plus 1. Okay. So as you can see that as the vegetation is increasing na, or more reflectance of NIR, it will comes to the value will be near the plus 1 value, or maximum will be plus 1. Okay, so our maximum range is plus 1, and if plus 1 is there, near values are near to plus 1, that means it is showing the vegetation. Okay, and if our value is 0, see when it will be 0, when the NIR and the red both will be equal. When the reflectance of NIR and the red radiations both will be equal, then it will be 0, and it happens in soil. You know why? Actually not exactly 0, but near to 0. You can say that if the vegetation is also there and moisture content is also there, okay, so vegetation will reflect more and more NIR, but vegetation will but water body will moisture content will reflect more and more red. So if there will be equal proportion na, then it will give the value near the 0. So near the 0 value, that means it is soil. Okay, so and when it will be negative, when the red this red reflectance is more comparison to NIR, then it will be -1 value, near to -1 value. See, and it happens in what? It happens in water. What it does, obviously we have already learned it, that water reflect more and more radiations in red region than the NIR. So obviously the NDVI value will be in negative. So this is the important point, okay, to understand ki +1 value will be near the +1 value will show us vegetation, near to 0 value will show us the soil. Okay, if it is dry soil, then the value will be towards positive. If it is the moist soil, more and more water is there, then it will value will towards negative. Okay, -1. And if there is near to -1 value, that means it is completely filled with the water, or it is the water body. Okay, so this is the important on the different, on the basis of the different types of the soil composition, this is also distinguished. Okay, here you see that negative values of NDVI, values approaching -1, corresponds to water. Obviously, here you see -1. Values close to 0 generally corresponds to the barren area of rocks, sands, or snow. Okay. And lastly, low positive values represent shrubs and grasslands, and higher the positive value will show the more the vegetation, means forest, temperate or the tropical rain forest. Okay. तो यहाँ पे किसी को डाउट, ये बहुत इंपॉर्टेंट टॉपिक है, तो अगर यहाँ पे कोई डाउट है, सो यू कैन टेल मी टू रिपीट, सो आई कैन, एनीवन, एनी डाउट? So see, this is very important point for the agriculture point of view. On the basis of this only na, we are using it in agriculture. Any doubt, anyone? See, there is the term green seeker. You know what is green seeker?
Uh,
What is green seeker?
Ma'am, it emits light in two wavelengths and then measures reflectance from the canopy.
What?
Ma'am, green seeker, it emits light in two wavelengths and then measures the reflectance from the crop canopy. I think I have read something.
So why we use that green seeker for application of what?
Ma'am, for nitrogen management.
Yes. See, that is green seeker is also based on the NDVI value. What it does that we take a green seeker, okay, and there is the row of vegetation. Here you see, this is the row of vegetation, okay. So we take a green seeker and we move from here to there, okay. Just मतलब जो ये क्रॉपिंग्स है, ओके, जो भी वेजिटेशन है, इसके ऊपर हम ग्रीन सीकर को लेते हैं और यहां से यहां तक ऐसे क्रॉस करते हैं. सो ग्रीन सीकर क्या करता है? ग्रीन सीकर जो है वही एनडीवीआई वैल्यू ये डिटेक्ट करता है एनआईआर बैंड को और रेड बैंड को, ओके, कि हाउ मच इज रिफ्लेक्टिंग एनआईआर एंड हाउ मच इज रिफ्लेक्टिंग इन रेड रीजन्स. सो ऑन द बेसिस ऑफ दैट इट गिव्स द एनडीवीआई वैल्यू. Okay, so NDVI value, if they higher the positive value, it means what? Ki our vegetation is good in condition. Okay, see 0 to +1 in between these. Okay, 0.4 to 0.7 is like that. So if we get see here, if we get 0.4 NDVI value in a field, okay, in another field we get the 0.7 value of NDVI. Okay, so what does it mean? What is the difference? It means having the low value, okay, low positive value, it means in comparison, it has the what? Lower vegetation. Okay, and here it is the more vegetation. More vegetation means we need here lower vegetation. Okay, low vegetation means we need more nitrogen to apply. So, you know, in that way, green seeker is used. So if the lower the NDVI value means we need to apply nitrogen. And you know, there is the relationship has been provided that on the basis of NDVI that how much quantity of nitrogen is we can apply. Okay, that on the base on in that is also that also gives the green seeker. Okay, that data also gives that key how much nitrogen we have to apply. If lower the positive value, that means we have to apply more and more nitrogen. Okay, so that is the application of green seeker. See, this is the agronomical point of view, but you know, for the plant pathologist also, this is used for the plant in the plant for the plant pathologist also. How you can detect the diseased plant? Okay, see, for the diseased plant, for the healthy vegetation is what? It should be more +1 value, near to +1 value. But if there is disease in plant or if so what will happen that there will not be healthy plants. Okay, so if leaf fall is there, so there will be low chlorophyll. Okay, so NIR reflectance will be low. See, if plant is diseased means what? Water lesions form is there, na? Plant is diseased, then what it forms? It forms the spores or different types of the pathogen, host of the different types of the pathogens. So it all will reflect low NIR. Okay, because it will cover the vegetation cover. Those pathogens will cover the leaf surface. So it will these plants will reflect less NIR region. Okay. So and if water lesions is there, so if water is there, na, it means NIR band will be observed more. So reflectance will be low. So obviously, if plant is diseased or having the low vegetation, it all gives the low NDVI value. On the basis of that, we can say that these plants are diseased. And you know, see, hyperspectral bands are there. You know, there are lots different types of the band. So on the basis of that, now we can also detect that which type of the disease is there, and which type of the crop is there. You see, all the green, all the NIR band having the different types. See, for the darker the green color, so it will reflect more and more NIR. Okay, so different plants having the different shades of green, different shades of green. So on the hyperspectral, with the help of the hyperspectral, even that difference also can be detected. Okay, so here that is the application of the NDVI in agriculture. So up to here, any doubt? We'll summarize. Okay, इतना समझ में आ गया ना? See, these are very basic concepts. बहुत कम लोगों को लेकिन ये सब concepts clear हो पाता है. So इन
Yes,
सब
ma'am.
हाँ, तो ये बहुत important है. So this is the interaction with the atmosphere. Okay, here you see these are the clouds. Solar radiations, when it is coming, when it interact with the clouds, then there is the scattered radiations. Okay, if directly it is coming, then it is called the direct radiations. There is a different type of the instrument in meteorology. You will study that direct radiations is measured by pyrheliometer, pyranometer. Okay, these are very important instruments. So remember those differences. Okay, so the important point is there. Okay, atmospheric windows we have already. Atmospheric windows or the spectral signature, both are the same thing. Okay, so here you see there are the different types of the wavelength. So this is important. So here you see thermal infrared region, range of the thermal infrared region, range of the short wave infrared region, range of near infrared region. Okay, here see, this is the important atmospheric scattering. One question I'm asking you people, that why rain bearing clouds is green in color? I think if you will apply those concepts I have studied right now, okay, if you apply, you will be able to answer why rain bearing clouds are darker in color or black in color.
ज्यादा पानी होगा, more absorption. There is more absorption.
Yes,
That's why it's
rain,
dark.
yes, Suman, you are right. What happens that rain bearing clouds are having the more water molecules. So water molecules, what it will do? It will absorb all the solar radiations. Okay, maximum solar radiations. So it will not reach to the reach to the our eyes solar radiations. Okay, so that is why rain bearing clouds are black in color. See, there are the different types of the scattering, relay scattering and the Ms scattering. So what is the relay scattering? When the size of the atmospheric particles is lesser than the wavelength of the incoming radiation, that is called as the relay scattering. For example, small dust particle, these are some molecules in atmosphere. So here see, shorter wavelength, okay, and are scattered more than the longer wavelength due to relay. So actually question will be asked that blue in color, blue in color of sky is due to relay scattering, Ms scattering, that kind of the question will be asked. See, so to remember that the blue of color of the sky is due to the relay type of the scattering. Okay, another one is the Ms scattering. When the size of the atmospheric particle is equal to the approximately equal to the wavelength of the incoming radiations. Okay, so that is called the Ms scattering. It happens, it is caused by the aerosols generally. Okay, that is the mixture of the gases and the water, vapor and dust. Okay, and non-selective scattering. This is also important, that the size of the atmospheric particles, when it is greater than the wavelength of the incoming radiations, you see clouds having this size greater than the wavelength, so it will absorb more. Okay, so So that type of the, and when it scatters na, so that type of the scattering is called the non-selective, because it will be in different direction, in all directions also. Diffuse type of the scattering will be also there. Okay, so that is why it is called the non-selective. So, and because of this, clouds appear white because it reflects all the colors, all the spectral regions. That is why it appears white. So questions will be asked that color of white color of the clouds is due to scattering. Type of the scattering will be asked, non-selective, my scattering, or if option is not non-selective is given in examination, then answer will be my scattering. Okay, remember this, because it is approximately same na. And here it is. Okay, effect of clouds. If sensor is there na, and see cloud is there, so sensor cannot detect the data of this region wherever. So when cloud is there na, so if data will not be covered by these sensors, so here it will be shadow. Okay, data here it will be absence of data. So for that, I have told you now that microwave radiations, microwave sensors is used. It can penetrate the clouds also. So here the solution of this problem is microwave sensors we can use, so that even in those cloudy or foggy situations also, it can cover those surface, and it can give us the data of at that time. See, this slide is important. From here in 2019 question was asked. I think for CO2 it was asked that which region of wavelength will be absorbed by CO2. 2700 micrometer, and I think option was there 1400 nanometer. Combination was given, even 1900 was given. See, for water all the infrared region will be there. Just remember like this. Okay, but for this oxygen, CO2 and N2 ozone, these are the very important. So remember this wavelength range. Okay, so that much for today. So if any doubt is there, you can ask.